with the Locating Epicenters I worksheet. This hopefully will give you a better visual of how to find and locate epicenters and like the process it might go to work, get through it better. Okay, so what I want you to see here is this is the earthquake epicenter. This is where everything started. This is the origin time. This is where the shift happened and caused the vibrations. So then going through here, this area right here is the distance away and the amount of time it took to get there. So the travel time. And then down here at the end, these are both the times of when it showed up at the seismic station. Okay, so when you are subtracting time, you need to make sure that you write it out the correct way, because if you try to subtract in this way, it's not going to work. You always have to have the later time on top. So I'm going to rewrite this so that I can see them being subtracted correctly. Normally we do this handwriting it out, but this is what we have to do right now. So, and then I got my little drawing tool, subtract, there we go. So now this one is kind of easy. You can see that it's going to be a 4-minute difference. So I'm going to write that down. My time difference is 4 minutes. Okay, so now I have to use the paper method. So I'm going to show you that using the reference tables.
So for 4 minutes, I've got to take my scrap sheet of paper. And remember, I like to fold it in half because it makes it a little easier to use. I have to go to and mark 0 and put a little line. And then I mark 4 minutes and I put a little line. And then I'm going to slide it up and over until the bottom line here touches the P wave and the top line here touches the S wave. And I can follow it straight down to figure out the distance, and it's at 2,600. So we write that on our paper. And then to figure out the P wave travel time, I would go to 2,600, follow that straight up, because if I know the distance, I know the travel time. So I go to 2,600, I follow that straight up, I followed across to figure out that it was 5 minutes for the travel time.
So now that I've used my reference table, I now know that the distance is 2,600 kilometers away. And I use my reference tables again, and I go to where the 2,600 is, and I follow it across to see what the travel time is, and that's going to be about 5 minutes. So I'm going to make sure I write this down here. 0, 0, 5 minutes. Oops. There we go. And now how I figure out the origin time is I have to take, let me get my little highlighting tool so you know what to use. I'm going to take the P wave travel time. That's not what I wanted. The P wave travel time, which is 5 minutes, and you're going to take the P wave arrival time and you're going to subtract the two. So you need to make sure you rewrite it over here that the P wave showed up at 12 o'clock. You are going to subtract the 5 minutes it took to get there. So if you are smart and savvy and you just count backwards from 12 o'clock, it would have been at 11:55. And they didn't use AM or PM, so you don't know if it's AM or PM or not. So that would be the origin time, because the origin time is always going to be earlier than the time it showed up at the P wave or S wave or at the seismic station. Okay, so let's do question 2 together. So again, I need to take my times. I've got to subtract them. So I'm going to rewrite them so that I see them in the correct way, just in case I have to subtract them a little differently. Okay. And it doesn't look like I do, so let's just make it look nice so that we can write this out. Here's my text box, which I'm going to write backwards. So 20 minus 0 is 20. 11 minus 5 is going to be 6. And then 14 minus 14 is going to be 0. So my time is going to be 6 minutes and 20 seconds. That's my difference. So I'll write that down here, 0, 0, 6 minutes and 20 seconds. Make sure you're writing it out with the zeros in front so that I know there's not hours in between. Okay, so now I've got to take this 6 minutes and 20 seconds and use my paper method.
Okay, so my time difference was, I have to mark my 0, and then 6 minutes and 20 seconds. And I'm gonna slide it all the way up over. And it doesn't quite fall at 4,800. And it's a little too much for 4,600. So it looks like we're gonna have to go halfway in between 4,600 and 4,800. So this one will be 4,700 kilometers. And then to figure out the travel time, because remember, if I know the distance, I know the travel time, I can go to 4,700, follow that straight up, and that took about 8 minutes for it to get there.
So after using the paper method, I found that it was about 4,700 kilometers away. So now I need to figure out the P-wave travel time, which if I go to my reference tables and I go to the 4,700 and I follow it straight up and I follow it across to get the time, I'm going to get, how long did it take for it to get there? It took 8 minutes. So 0, 0, 0, 8, 8 minutes. So now how I figure out my origin time is I have to take the time that the P wave showed up, which is 14:05:00, and then I have to subtract my 8 minutes. Okay, so I put my little drawing tool in so I can see this, and oh dear, I do have to do some borrowing. So I'm going to borrow next door. So this was 13, looks like we're using military time. So then this, I have to add the 60 minutes to the minutes that are already there because I'm borrowing from the hours. So 65 minus 8. I'm going to use my handy dandy calculator because my brain's not working correctly today. And I get 57. So it was 13:57. So here's my text box. So 13:57 is when the earthquake started. Go ahead and do the rest of this on your own as practice. I will post the answers at a later date so that you can check your answers. Thanks.